So today continue the previous class capacitor and capacitance. So previous class we discussed uh, what is a capacitance and what is a capacitor, and charge is proportional to absolute value of charge directly proportional to potential difference between these two plates. Okay, that is a V, and Q equal to CV and C equal to Q by V, and get a SI unit of farad, SI unit of SI unit of SI unit of capacitance is farad, and farad is a very large big value or large value. Okay, so what the amount of large value? So we check some earth surface. Okay, the potential V of calculate the potential of the earth surface, and then we get a C value, capacitance of the earth. Now how to charge the capacitor? Okay, so charge the capacitor means before the connecting battery, so there is a neutral line. These two lines are the neutral, no charge here. After connecting the battery, so the potential difference may be created here because the electron move in that direction, so get positive here, and the negative goes in that direction, so get negative here. So there is a difference between these two plates. This plate is positive plate now, and this plate is the negative plate, and there is a generated some electric field here. The developed electric field create an potential, because we know that V equal to E times D. What is the D? D is the separation between these two equipotential surface of plate. So if create a V, and we know that V is directly proportional to Q, and Q is the absolute value of charge. Okay, so we get some value of capacitance. Okay, and Vc is the capacitive voltage because that electric field. Okay, so capacitive voltage means is a capacitor generate a voltage, generate a potential difference in between these two plates, or a capacitive potential. Here a potential difference these two plates is a potential. That potential is a Vc. Okay, that's the SI unit is volt, and it's called a capacitive voltage. Vc, that is equal to maximum value of Vb, the battery voltage. And when Vc equal to Vb means the capacitor have full charge. Charge means here actually the generating the potent charge means positive charge here, negative charge here, and due to this difference create an electric field. When electric field be created, then obviously the potential also be created. Potential difference maybe obviously I created here. That means is called a charging of capacitor. Now how to charging and how to discharging a capacitor via load we discussed the previous class. And how to calculate capacitance in two parallel plate capacitor, and what is a dielectric, we know that the method one, how to calculate capacitance. Here is a various another type of method how to calculate capacitance. So here we get from previous class, that is charge, absolute value of charge is directly proportional to potential difference between these two parallel plates, and that is Q equal to CV and C equal to Q over V. Okay, and now the interesting thing is that there's two plate here. Suppose these two plate. So one plate generate positive and other plate generate negative. So what is the area? Capacitance depending on area. Area means that area of the equipotential surface. So actually be the area between these two are parallel line. So area be the same. So if C is directly proportional to area A, if A is more, the C is more. If A is less, C be the less. Okay, and that's the area of that equipotential surface. That area is the area of equipotential surface. And what is the D? D is the separation between these two plates. So C is inversely proportional to D. So if D is large, so C obviously is small, and if D is small, C be the large. That C means a capacitance. Okay. Here we discuss another method to calculate capacitance. Previous class we discussed how to calculate capacitance. C means a capacitance of two parallel plate capacitors. So here obviously we discussed how to calculate capacitance. So another method, calculate capacitance. Calculate capacitance. Okay. So another method. Okay. So check the method is. So here there is the two surface here. So the bottom of that upper surface get positive charge, Q. So charge density with the sigma is greater than 0, and top of the lower surface get negatively charged. Obviously the absolute value will be the same, minus Q. There is a plus Q, there is a minus Q. Okay. Now the electric field in that direction. Okay. So here sigma is less than 0. So D is the potential difference between these two plates. Okay. Now we want to calculate capacitance. Okay. So capacitance equal to charge over potential. So what is the potential? Potential is the potential difference between these two plates. Okay. So now we choose three surface. Okay. One surface is outside here. Here choose the another surface or region here, and we choose the another region here. Three region we choose. Okay. So in first region, okay, in case of first region, so electric field will go actually see that in that direction. Means here outside that surface, electric field will be the 0. The electric field will be the 0, because the electric field from Gauss's law we know that E is equal to sigma over epsilon naught. In these two surfaces actually, two surface here, the actually electric field bound here, not actually here. So outside that here the electric field will be the 0, but here same case electric field will be the 0. So here that in region 1 and region 2, from the application of Gauss's law, we know that how to calculate electric field in a surface. Okay. In a sheet, we know that. In a sheet here, a positive charge. So that is the area in that direction E. Similarly, in that direction, so E times as a 2A. Okay, area means that twice A. That is means sigma over epsilon naught. So here that is a Q. So Q means here put Q by A. Actually that E dot A, that is some Q, and that now A be the here. So E sigma over A to epsilon, sorry, Q over A. So Q over A be the sigma over twice epsilon naught. Okay. So here we see that if electric field be the 0, so both are cancel each other. Okay. In outer region of these two plates here, that is E total equal to sigma over twice epsilon naught. One surface and another surface is a minus sigma over twice epsilon, so that is a 0. Now here in region free. Okay, in inner plate between these two, we plate H plate and here with the L plate. In here the bound okay, so electric field is a two plate is added up. Okay, because electric field in that direction, here electric field is obviously in that, both electric field in same direction. That is, here from we know that electric field with sigma over twice epsilon naught. Okay, so actually this electric field, okay, one direction, is bi-direction, that is sigma over twice epsilon naught. Okay, remember that. And here be the same minus charge, so minus minus be the plus sigma over twice epsilon naught. We get twice sigma over twice epsilon naught, to cancel these two twice, so sigma over epsilon naught. So we get the value of E, and we know if you want to calculate capacitance, that is first to calculate electric field, then value of electric field to V. So V equal to E times displacement here, D, displacement here, that gap between these two plates, and here you get that is E equal to sigma over epsilon naught times D, that is equal to V. Okay, now what is the value of Q, charge, in the sigma? Here in sigma you get charge from sigma, so that is equal to sigma equal to Q over area epsilon naught A times D. Now this V put here, you get Q over V, you get Q over D epsilon naught times A, these two Q are cancelled, so epsilon naught A over D. Okay, we check these two values are same. C equal to capacitance equal to epsilon naught A over D. Okay, with the help of Gauss's law, you can also calculate capacitance of a parallel plate capacitor. Okay, with the help of Gauss's law. So that is, we get capacitance, that is equal to epsilon naught times area, surface area means actually, and D is the gap between two equipotential surface. Now we calculate another interesting, how to energy store in capacitor and how much energy store in capacitor. Discuss energy store in capacitor. Energy stored in capacitor and how much energy stored in capacitor. So here is a two surface, one surface actually we choose here, one surface here and other surface be the here, two equipotential surface. Okay, so lower part of the surface, upper surface with a positive charge, and top of the lower surface with a negative charge. Okay, so there is an electric field in that direction. So outside that surface, electric field with the zero outside the surface, means outside that equipotential surface with a zero. Here electric field with the zero, so gap is the D. Okay, so here another important question arises here. In here you see that very carefully inside. So actually electric field look like this or slightly bend, look like bending like this. Okay, not all look like a state, actually with a bending. Why? So here the concept is that in center electric field is maximum, okay, in between these two plates, because you know that if there is charge, positive charge here, negative charge here, when the out at that point here, so there is a, at that point electric field is weak, and here the electric field is more weak. Here the electric field is more weak. And take some distance here from that point here, so electric field is weaker. Similar case here, electric field is weaker. So that's why the bending. That's why the bend is created. But there is a no bend because there is a strong field, and here is a weak field, and here is very weak. There is also a very weak field. So electric field actually in center is the maximum. When the slide in that direction here, when in that point, so there is a field is weaker, and is more weaker here, more weaker. So that's why there is a bending. Okay, that's why there is a bending like this. Okay, and there is strong field here, so weak field in that region. Actually, depending on what these are bending, these are in between these area. Okay, this is dielectric. Depending on dielectric, what type of bending and how much bending depending on the dielectric. Okay, and the area also. So this is called fringing of the field. Field. Okay, and you know that capacitance C, that is equal to epsilon naught A over D, and we also know that potential V, okay, that is equal to E dot D. Clear? Because there is some distance created, that is a bending, that's a weak field. Due to that weak field, so electric field line is bending actually. Okay, that is the field is bending here. This line is not straight, it is a bending. Okay, that bending is called fringing of the field. Okay, now if you want to calculate energy, now this surface move upward, work done to move that surface here. Move here, and that's the x increment of d, x increment. When this surface, upper surface move here, so after moving, so electric field is not equal to 0. After moving, before moving, electric field will be 0. After moving, electric field is not equal to 0. So here, the very important thing is that the charge with a plus q, here charge with a minus q, the absolute value, and here the sigma is greater than 0, here the sigma is less than 0. When that surface move upward, so there is a work done. Okay, there is a work done, very important, work done by the external force, move upward. So work done, we know that it is force external times and displacement. Here the displacement in upper surface with the x, and we know the force, that force is electrostatic force, that is equal to q times electric field. Okay, times that E is not external, obviously, sorry, QE times X, and okay, now the thickness, and what about thickness, thickness of the surface, the thickness is very small, and we choose the thickness is very small. For good capacitance, we choose low value of D, so A is greater than D for good capacitance. Okay, now here the work done. Now the work done by the external force. Okay, so work done by the external force, that is equal to the electric field E, and that is force external, that is equal to Q times E, and here the average electric field. So here the electric field be in that direction. Okay, then we all know that E equal to sigma over epsilon naught, but here the average upper part be the 0, so that is a 1 by 2. Okay, so that is F external, that is half of Q E, half of E, because the average 0 plus D, so that is by 2. So E average equal to 0 plus sigma over epsilon naught by 2. So that is 1 by 2 sigma over epsilon naught. Okay. So that is means say that electric field be the half. Okay. So here that 0 plus this electric field, that is Q times E. So that means the QE half actually. Actually we say that is a QE is a half. The half F external actually be the average. Okay. So that is the average equal to E average equal to E upper part is 0, but E lower part, that is 0 divided by 2. Don't confuse that equation. Okay, so that is equal to E average. You consider E average, so E total, that is E by 2, EL by 2 actually. So that is equal to Q times, that is EL, or put here EL, that is E times X, this place. Okay, and here from charge Q, so we are doing some algebra, that is 1 by 2. Okay, now multiplied by A in numerator and denominator, E times X, that is equal to 1 over 2 Q over A, that means sigma A E X. Okay, now we put same concept here, epsilon naught multiplied by numerator and denominator. So sigma over epsilon naught, sigma over epsilon naught means E times A times E times X, that is half of E square A X, and here the epsilon naught, sorry, these two epsilon here. Okay, that's the work done by the external force. Now work done by the external force. So if you see that, that's the area, that's the area, surface area A, and this place in X. So work done per unit volume. So here we calculate work done per unit volume. Work done per unit volume, that is work done by the external by volume. That volume means half E square A X epsilon naught. So volume, if you see the diagram, so that is a cuboid. So base area times height. So base area be the A and height be the X. So cancel these two. That is equal to half epsilon naught E square, work done by the volume. Okay, don't be confused, there's a volume and potential. Okay, if you don't confuse that, I put a volume, so VOL stands for volume, or potential stands for capital V. Both symbol are V. Okay, so there is a confusion. Okay, so SI unit is a joule, and volume is a SI unit is a meter cube, joule per meter cube. So the energy, work done associated with energy. So energy U potential energy, that is equal to integration in all space, or okay, volume, that is equal to U, that is half epsilon naught E square times volume integral dV, and that is a V stands for volume integral here. That's the energy. Now you see that energy, the integration. Okay, so here integration half epsilon naught and here E square, E means sigma over epsilon naught, so sigma square over epsilon naught square times dV. These are all constant, so outside the integration half, so cancel these two, sigma square over epsilon naught integration with the dV. So integration of dV, that is to get a volume V half sigma square over epsilon naught as a volume. So half sigma square over epsilon naught volume with the base area times height x. Okay. So now half the sigma over epsilon naught a times x. Sigma over epsilon naught is E, that x here times a, and Ex means length. So half sigma here and that area, surface area, that's the potential. Okay, that's the potential. Okay. So sigma A V. And what is the value of sigma A? So sigma surface charge density, that is equal to Q over area. So sigma times A, that is equal to Q. So half of QV, that's the energy stored in capacitor. The energy stored in capacitor. The total energy actually created by the field. So total energy in the field. The total energy in the field. Okay. So now Q equal to CV, and so another key, that is a Q equal to CV. So put half CV times V, that half CV square. That's another value of potential energy. E equal to half CV square. Okay, so energy means joules. Okay, so joules. S energy is joules. Okay, so that energy stored in capacitor. That energy stored in capacitor. Okay, very easy concept. There is actually a mathematics. Okay, there is some algebra, and you know the equation, put the value, and that is very important. The calculation or derivation, mainly derivation is very important in board exam. Okay, with a careful and practice 2 or 3 times, so very easy actually. Okay, next class we discuss the alternate method to calculate that the energy stored in capacitor. Okay, the alternate method, and okay. So if you have any doubt in that section, always comment section will be open. So today I end the class here. Thank you.